Welcome to Systems of Linear Equations, lesson number 2. This lesson is going to focus how do we determine the number of solutions to a system of equations. So we've been looking at when two lines meet, there's one point of intersection, and we say then that there's one solution. So we're just going to look at a couple different scenarios and see if there are cases in which we might have less than one solution or more than one solution. So the example we're going to use to introduce this or to explore this topic is to imagine that 3 students are placed in 3 different burger restaurants. So Burger Shack, Big's Burgers, and the Burger Haven. And so we record a couple of the orders, how much it costs for a combination of burgers and salads. And then we go and we try and state, like, if X is the number of dollars that you would pay for a burger, or X is the cost of the burger, and Y is the cost of the salad, what is X and what is Y, assuming that all of the prices are the same among the restaurants. So we're going to take a little bit of time here, and we're just going to write in terms of X and Y. We're going to pull the information listed up above here and write a couple of system of equations. So I'm going to focus on the Burger Shack first. It says for the first order, Deja charges $28 for 4 burgers and 2 salads. So 4 burgers, 2 salads, assuming X is burgers, Y is salads, equals $28. And at the same restaurant, $34 for 6 burgers and 1 salad, or a salad. So 6 burgers and a salad, $34. Okay, and then we go to Big's Burgers, and we're just looking at the cost now at Big's Burgers, and then we can compare it and see sort of when their prices will be the same. So Shelly charges $18 for a burger. So Shelly's working at Big's Burgers, $18 for 1 burger and 3 salads. So X plus 3Y equals 18. But $54 for 3 burgers and 9 salads. 3 burgers, 9 salads, $54. Okay. And at the Burger Haven, that's where John's working, charges $32 for 2 burgers, so 2X, 4 salads, 4Y, $32, and 3 burgers and 6 salads cost $42. And so I'm using what they've had here. They said X is the cost of burger, Y is the cost of dollar, translating each of those sentences into equations. Now, considering the system of equations, or sorry, you're not comparing. I said earlier you were comparing among the different restaurants. You're not comparing each restaurant. Trying to find out the cost of a burger and the cost of the salad at each restaurant. And so you could almost extend this question and say, like, if they're, where is it the cheapest, or that type of thing. So at the Burger Shack, can we write both of these equations, Burger Shack, these equations, in terms of Y and use a graphing calculator to determine the cost of a burger and a salad? Okay, I'm going to start by copying down my 2 equations. So I had 4x plus 2y equals 28, and also under the Burger Shack, 6x plus y equals 34. Getting these into y equals, this one is kind of easier because y is already 1y. So I just got to take away the 6x or isolate the y to get y alone, and negative 6x and 34 on the other side. And over here, I'm going to keep y, take away the x to the other side. I want x on the side of the numbers. I got 28 minus 4x. Now, it doesn't really matter now because I'm not looking at slope-intercept form, so the order is not crucial here to compare. I'm going to divide both sides by 2, and I will get, I'm just going to write it up here, y equals 28 over 2 is 14, 4 over 2 minus 2x. And so I have 2 equations here in terms of y. I'm going to let one be y1 and one of them be y2. And I'm going to in my graphing calculator. So in y1, you can see our work from the last lesson is here, 14 minus 2x, y2, negative 6x, negative 6x plus 34. And so I've got one of them in y1, one in y2. I'm going to graph them to see if they intersect. If not, I'll change my window. And then I want to state what the solution is. So I see they cross right here. There are two lines crossing once. So I'm going to calculate that intersection. It says first curve, enter, second curve, enter, guess, enter, 5, 4, or x is 5, y is 4, which means in terms of this problem, burgers are $5, salad $4. Okay, and I'm just going to do a quick sketch to go with this here that shows sort of this one going down and this one a little bit steeper. Oops. Okay, and then this is going to be my 0.5, 4. So not quite to scale, but I just want to show that there's two lines and that they're crossing once. As I go to Big's Burgers, under Big's Burgers we had two equations. We had x plus 3y equals 18, and we also had the equation 3x plus 9y equals 54. And so writing these both in terms of y equals so that we can graph them, we need to get y alone, x and the number on the same side. So I'm going to take away x here, both sides, 3y 18 equals 18 minus x. To graph y equals, divide by 3, y equals 18 divided by 3, 6, minus 1 divided by 3, x. And so I could have even left it in this form. That would be a form that I could graph, but this would be a linear equation, and since that's what we're studying, we might as well work towards that. 3x plus 9y equals 54. Try to do the same thing with it. So 3x I'm going to take away, and I'm going to be left with 9y equals 54 minus 3x. Divide by 9 on both sides to get it in y equals. Y equals 54 divided by 9, 6. 3 divided by 9, 3 or 9 are both divisible by 3. That would simplify to 1/3. You can double check that on your calculator. And x is 6. So now I'm looking here. Both of these lines are the same. So let's just try to graph one of them, because they're going to be the same line. They have the exact same equation. I just want to know what this line kind of looks like. 6 minus 1/3 x. All right, there it is. Now, I were to graph both of these. I can even try. They both have the same equation, 6 minus 1/3 x. Now, I'm not going to see a difference on my graphing calculator. It's drawing the graphs totally over top of each other. And so it says, can you determine the cost of a burger and a salad? No, that's the same line. I can't find out where sort of the cost of the two orders would meet and be able to find what the burger and the salad cost. So the same line, I'm going to say no. Okay, so that system's not quite useful to me. Let's go to the Burger Haven, our third. 2x plus 4y equals 32, our third restaurant. And I'm copying down the equations we said earlier about what the burgers and salads cost. And once I have that, I want to rewrite what the equations are in the y equals form. So my same process all the time. Keep y, take away the x and with its coefficient, the 2x in this case, on both sides. And once you've done that, this needs to be 1y equals divide by anything that's in front of y. Y equals 32 divided by 4, 8. 2 divided by 4 is 1/2 x. And so now I want to go ahead and say, okay, 3x plus 6y is 42. Same idea. Keep y, take x to the other side, and then divide by 6. 42 divided by 6 is 7. 3 divided by 6 is 1/2. And so if I go to graph these, they are different. So I'm going to put 1 in y1, 1 in y2 for comparison. And maybe you've already noticed something special about the lines in terms of their slope. But if not, we'll check. 8 minus 1/2 x. 7 minus 1/2 x. Here's the two lines coming up. I'm going to do a quick sketch. And I can see now those lines are parallel. In fact, if you look close, they're very equally spaced all the way across. And I can tell down here the slopes are the same. So these ones are actually, in fact, never going to meet. And so it says, can you determine the cost of a burger and cost of a salad? No, the lines are parallel. And how can you tell that the student must have made an error in one of the calculations? And so if we're sort of getting two parallel lines for two different amounts of food, and we go down and we try to sub in some values of x and y, what's going to happen is that we're going to get the fact that ordering a burger and a salad is going to have two different prices. So we don't want two different prices for the same amount of food, so there must have been an error in one of our equations, but we don't have to find it out. This is the three ways of looking at how many solutions there are, and we're going to be in three scenarios. I'm going to fill in this chart before we go up here. You can have one solution in which you're going to see on your graph, anywhere on your graph really, two lines intersecting. Or you might have no solutions, zero solutions, because you're never going to have a point of intersection because your lines are parallel. And the third case is to say you're going to have infinitely many solutions because your lines lie perfectly one on top of the other, and so all of the xy pairs now are solutions to our system. And so if you're looking in terms of slopes and intercepts, we are looking for different slopes in order to have two lines meet. And then we're looking for what to be parallel, the same slopes, but we're going to add on the condition that our intercepts have to be different, because if our slopes are equal and our intercept, our y-intercept is equal, we're going to get that case where we have the same line, and then that's when we say there's infinitely many solutions. And so it says graph each system of equations on the grid provided, and determine whether it has one solution, no solution, or infinite number of solutions, or state the number of solutions to each system. So I'm going to go up to the top one here, and I'm going to graph. I have, this helps me now that I filled in that chart, this is easier to look at. X plus 5, negative x plus 1. Different slopes and different intercepts. But as soon as they have different slopes, that means they have one solution. And I'm going to verify that with my graphing calculator. These are nicely in y equals already for me, so I'm just going to go ahead. The top one is going to be y1, x plus 5, and the bottom one is going to be y2, negative x plus 1. Graph it. There's my intersection. So I'm just going to draw that. Or I'm good. Try and draw a small picture that shows that there's an intersecting over here. Looks around -2, 4 maybe. but it doesn't matter. Just state the number of solutions. So I don't want to worry about what the solution is. I just want to worry about how many solutions first. When I look here and I compare now, I see same slope, different intercepts. Slopes equal, intercepts are different. They have the same slope, and so this one is slope 2 at intersection +6. So let's just draw one about right there. And then same slope, but at the intercept of -8, so somewhere down here. So those lines are going to be parallel. We're going to have no solution. They're never going to meet. And I wish they would have kept the trend going here and kept this in terms of y equals, but I'm just going to verify what that is in terms of y equals. I'm expecting, based on the pattern, this to be the infinitely many case. So in this case, I'm just going to add 2y so that my x and my numbers stay together, and y is on the other side. 6x minus 4 equals 2y. Divide by 2 on both sides for y equals 6 divided by 2, 3x, -4 divided by 2, minus 2. And so the line is 3x minus 2. Same with this line. That is the exact same graph. Y-intercept -2, slope 3, somewhere down there. In fact, that's probably a little bit of a too shallow of a line to be a slope of 3. But the idea is that our lines are coinciding on top of each other. We're going to say an infinite number of solutions. Okay. So this is a good kind of chart to compare when you will have one solution, 0 solutions, or infinitely many solutions. When you're working with linear equations, these are going to be your 3 cases: 0, 1, or infinite number. You're not going to say 2 solutions. Okay, because you can't get 2 straight lines. Find a way to draw 2 straight lines and have them intersect only twice. We need a bend in the line to do that, or at least one of the lines. So we don't see that this year, but we see that next year. Okay, go through ABC without graphing. Analyze whether it has 1 solution, no solution, or infinitely many solutions. You should be first looking at the slopes, if you can, if they're in y equals mx plus b form, and then looking at intercepts if need be. So I'm going to look at A. This one, nicely in a y equals form already. That would be mx, slope -3/5. There'd be plus b, would be like plus 0 behind here. But I want to look at this one that's kind of in almost a general form, but not equal to 0, rather the c value is on the other side. 3x plus 5y equals 15. I'm going through the same process I have been in these lessons by taking away the 3x on both sides, so that, and I'm just going to write the -3x now first rather than second, and to isolate y first, and then you need 1y. So you're dividing by coefficients after that to say y equals -3/5 x. That -3 divided by 5, 15 divided by 5 is 3. And so I'm looking at these 2 lines. It said I can't graph it. So slope -3/5, slope -3/5. These lines have the same slope. They're parallel. But then I want to know, if they're parallel, are they the same line? This one is no y-intercept or plus, well, actually I shouldn't say no y-intercept. Y-intercept is 0, y-intercept is 3. So in fact, they're not on top of each other. They would be parallel and distinct, separate from one another. So parallel and distinct lines never meet. They have no solution. Okay. I'm going to go up here now, same process. Y equals 1/4 x plus 2 is one of my lines in y equals form already. I want to look at this one, and I want to know what the slope is, or if there would be a number of solutions. So x minus 4y plus 8 equals 0. I need x and the number on one side. y on the other. I'm going to choose to add 4y. Add 4y so that x plus 8 equals 4y plus 0, which is 4y, and then divide by 4 because it's got to be 1y. I can imagine that there's a 1 in front of that x. 1 divided by 4, a quarter x. 8 divided by 4, 2. Quarter x plus 2. This one's also a quarter x plus 2. That's the exact same line. They have the same slope of 1/4. They have the same y-intercept, positive 2. They must be the exact same line, infinite number of solutions. Okay, and this last system here requires a little bit more work on my part to change forms. 7x plus y equals 12. Keep x and your number on one side together. So in this case, y needs to be isolated. Take away 7x to do that. So 12 minus 7x is on my right side. I could rearrange that to say negative 7x plus 12, same thing. Over here, I'm going to do the same thing. I'm going to take away the x so that I get negative 6y equals 5 minus x, an extra step to divide by the negative 6. 1y equals 5 over negative 6, or negative 5, 6. Negative divided by negative, that's a negative 1 divided by negative 6. That's positive 1 over 6x. And so I can tell now, not the same slope, because I'm seeing a slope of 1, 6 versus a slope of negative 7. As soon as I have different slopes, there's one solution. Okay, so it's not asking what the solution is, asking how many solutions on this page. Okay. I think we got one more example left in this lesson. It says for the title, can we solve or work towards solving a system graphically by changing the calculator window? And so you should be familiar with changing the calculator window because we've looked at that when we studied relations and functions. We're going to read through the problem, try to write out or draw two graphs, and then we're actually going to rely on our graphing calculator in this case to solve the system for us. So here's the problem. At a local high school, the student council decides to sell sweaters to the students. The cost of designing the sweaters includes a fixed cost of $600 plus $5 per sweater. Okay, so I'm seeing here the dollar cost D, $600 plus $5 per, or times N, or where N is the number of sweaters, so $5 per sweater. Okay, keep reading. It says the students' council plan to sell the sweaters for $25 each. The cost and revenue can be modeled by the following systems. And so now I'm seeing this one is actually the cost, but this one is the revenue. Say the dollar revenue is $25 times, oh, they wrote that for me. There we go, $25 times the cost of the sweater. Use a graphing calculator to graph each system and sketch each graph on the grid. Now these are not in terms of X and Y, but I can easily convert them to that. I want N to be my independent variable. I want that to take the place of X. So I'm gonna just rewrite where these two equations where D is equal to Y and N is equal to X. And then I'm gonna graph. Okay, so I want to graph this, and so I'm gonna put in 600 plus 5x for Y1 and 25x for Y2. Graphing it, and they're showing me this example because the solution is going to be beyond your standard window. So we need to work on adjusting our window, and so I'm actually going to kind of mimic the window they have set up here where they say X goes from 0 to 50. So I'm going to hit window, X, changing it from 0. I might as well make that negative 10 maybe so I can see a little bit further. Negative 10 to 50. And then Y from negative 100 to positive 1000. So sorry, here's my X min, X max, Y min, Y max. You can take a second to pause ever if you need to look at that as well. Graph, and now I see my window has changed. And eventually, so this graph drew first, that'd be my cost. Here's my cost, here's my revenue. Eventually there's gonna be a point where cost equals revenue. But for the meantime, it says, can you answer a number of questions related to this? So how much profit or loss is made if 20 sweaters are sold? How much does it cost you to make 20 sweaters? $600 plus $5 per sweater. That's coming up from up here, 600 plus 5N. So if I add these together, 600 plus 5 times 20, that's 600 plus 100. $700 to create the 20 sweaters or produce the 20 sweaters. How much money do you make off or make if someone buys those 20 sweaters? You're selling them for $25 a piece times 20 sweaters. 25 times 20, go on your calculator and check. That's $500. And so you can see your costs now outweigh your revenue. This is actually a loss, about $200. You're not going to make back your full cost. And if we go to maybe selling more sweaters, 50 sweaters are sold. Well, how much does it cost to make 50 sweaters? $600 is the fixed fee. 5N, or 5 times the number of sweaters. 5 times 50. 5 times 50 is 250. Plus 600 is 850. Whereas your revenue should be a little bit higher, because revenue is $25 times the number of sweaters, assuming you sell them all. 25 times 50 is $1,250. And so now I can see my profit is actually more than my cost, and it's about $400 more. So my profit is $400. And so in C, it says breaking even means you have no profit or no loss. In other words, profit equals loss. And this is a system of equations problem, because if I do a quick sketch of my grid here, actually I'm gonna just hold this here for my sketch. So here's my cost, my revenue. I want to know, when does cost equal revenue? When do they meet? When do the same values of X and Y occur? And so I want to find that intersection. I hit second calc intersect, enter, enter, enter. When X is 30 and Y is 750. So I'm just going to write, in case I forget later, that this was the intersection. X is 30, Y is 750. In the context of my problem, Y was related to the dollar amount. So at $750, X was the cost, or sorry, not the cost, the number of sweaters. N was replacement for X. So how many sweaters do you need to sell? You need to sell 30 sweaters. Okay. And if you sell 30 sweaters, your cost will be $750 and your revenue will be $750. You will break even. In part E, if all 850 students in the school purchase a sweater, how much profit would you make? Well, you got to first produce or pay to have those 850 sweaters made, which we said was 600 plus 5N, where 600 plus 5 times 850. Can't do that one in my head. So 600 plus 5 times 850. 48.50 or $4,850. Revenue, if I sell 850 sweaters, $5 a sweater, or 5N was my equation, or sorry, $25 a sweater. 25 times X was my equation for my revenue, or 25N. So 25 times 850, 21,250. And it says, what was the profit? So profit is your revenue minus your cost. So actually, so you can see there, if I just hit the subtraction sign, it's going to record answer. I'm going to take away my costs. $16,400 would be my profit. Okay. So we finished lesson number 2. Take a second to either log on to Google Classroom or get a head start on your homework. If you want to do it all, you can. If not, go take a look at what my assigned questions were for you, and you can get to work.